Hello there, and welcome to video number 199. This one is on relative frequency, and the keywords I've got for you are relative frequency, experimental probability, fair or biased. Now, relative frequency and experimental probability are pretty much the same thing. Relative frequency is the chance of something happening based off of doing an experiment. So if you work out how many times something happens and then you put it out with the number of times you've done the experiment, you've got the relative frequency. Experimental probability differs from expected probability because expected probability is calculated without doing any particular practical experiments, and fair means that something is done without favour to one thing or another, and biased means it has been favoured over another thing. Relative frequency is an estimate of probability based off an experiment that's been performed, kind of like what I've mentioned already. You get some results that you need to use to calculate the relative frequency in lots of questions. Take the number of times a particular event happens and divide it by the total number of times that the experiment has been done. That gives you the relative frequency. And in some questions you might be asked to comment on how fair the test is or how you could improve the test that has been done. In question number 1, you've got Dougie who took the train to school 130 times in a school year. The train was late 26 times. What's the relative frequency for the train being late? Remember, what we're doing here is calculating an estimate of the chance of that happening, again, based off of the experiment that's been done. So we take the 26 times it was late, we put it out of the 130 times that he went on the train, and we've got the relative frequency as a fraction. We could convert that to a decimal, which gives us 0.2. I've just done this question, so I know it gives us 0.2, but here you would type it into the calculator here, and you would get 1/5 as a fraction or simplified fraction, which is 0.2. Right, that means that's 20% of the time the train is late. Or obviously there are various different reasons why trains might be late, but the estimate of probability, we're going to say it's 0.2. Now, in question number 2, we've got a football team played some games. They lost 28 games. They had a relative frequency for a win of 0.25. 25% of the time they won a game, and as 0.4 of a draw, so 40% of the time they drew. And you can always think of those decimals as percentages quite easily, but if we add those decimals together, 0.4 plus 0.25, all right, and we added then the relative frequency of the loss, then we are getting one whole amount, because those events are mutually exclusive. You can't win, lose and draw at the same time. So you have to only do one of them at a time, so therefore that's why they will always add up to 1. So we can take that 0.65 those two add up to, away from 1, 0.65, and that gives us 0.35. Okay, remember that's 35% of the time they lose. Right? If we think of that as a fraction, if we're trying to do this question without a calculator, we could do it this way. It's 35 out of 100 games. Obviously, they lost 28 games. 35 is not 20. We want that top number to be 28. So let's cancel that fraction down. Divide both those numbers by 5 gives us 7 out of 20. And then if we multiply both those numbers by 4, we've got 28 on the top. And that will give us 80. Now, that is 28 games out of, and now we've got the total number of games. You can see it there. That's how many games they played, 80 games. And that is our answer for that question. All right, so it's a tricky one. If you had a calculator, you could easily do that with just reversing the process. So you could take I'll just do that on the calculator for you actually. So if we took the number of games that they'd won and we divided by 0.35, oh, come on, 0.35, the relative frequency, we would get 80, all right, which is how you could do it with a calculator nice and quickly if you were allowed one, all right, which in most of these times you probably will. Now, in question 3, samples are taken from a light bulb production line. 600 items are checked in each sample. This is stuff that happens in real life, isn't it? They check these samples to make sure that they're not sending out duff stuff. The relative frequencies of the number of 40 items in 5 samples are shown. So we've got 0.06, 0.05, etc. Sample A, B, C, D and E, 5 samples. Work out the range of number of 40 items in the 5 samples. So the actual number, not the range in the relative frequency, is the actual number. Right? So if 600 items are checked in each sample, we can work out how many were duff in sample A by doing 600 multiplied by the relative frequency. All right, if we multiply the relative frequency by the number of items that were checked, we will get the actual number of Duff items. So 0.06 multiplies by 600 to give us 36. Okay, that's this one. I'm going to write it all underneath it actually. And then we take 600, we multiply by 0.05, and that's going to give us 30, isn't it? Okay, without the calculator we can get that, hopefully. Maybe, I'm not sure. But that's 30. This one, 50, 0.015, multiplied by 600, I think it's going to give us 9, isn't it? Yes, 9. All right, there we go. And this one, I'm not writing down on my work in here, but I'll show you what I've done. 600 multiplied by 0.015 is 9. This one is going to give us 3. And this one is, let's just write that one down as well, equals 3. And then 0.01 is going to give us 6, isn't it? So 0.01 multiplied by the 600 is 6. Okay, so you can kind of do that in your head as well if you want to, but you've got your calculator. Multiply the number of items that are checked in each sample by the relative frequency. All right, whatever this question is about, always multiply the two things together to find out the actual number of things. So the range of number of 40 items, we've got them all sitting there. 36 is the largest, 3 is the smallest, so what we're going to do is 36 minus the 3 to give us our answer of 33. That's all we need to do. That's the range of number of 40 items in the 5 samples. Okay, so the last question there is a little bit in depth, isn't it? It's a little bit tricky, but hopefully it makes sense. In essence, very simple to work out a relative frequency. You just put the number of times that something has happened out of the total number of times and you've got it. Okay, we don't need to make it much more complicated than that. But obviously there are maths questions that are. Take care of yourselves, look after one another, and I will see you whenever you watch another one. Bye bye.